Okay, so we've got here normally distributed, mean of 39, standard deviation. So we can write our statement now, which is x is distributed normally, and what's in the brackets? So it'd be mean and standard deviation squared of variance. So if we write that out, normal distribution, the mean is 39. Okay, standard deviation is 6.1, so we've got 6.1 squared. All right. So we've got that information, and it says find the probability that a trout caught in the fish farm is less than 35 centimeters long. Okay, so what's the first step? So I said to you, the first step I would do always, when it tells me it's normally distributed, is to draw your curve, yeah. Just so that you can visualize, okay. The line down the middle represents the mean. So the mean there, all right, is 39. And then the standard deviation is 6.1. So I'm not going to worry about putting that on my graph at the moment. Okay, so when we do that, it says find the probability that a trout caught in the fish farm is less than 35 centimeters long. So where does the line go for that piece of information? Yeah. So if I just put, I don't know how far it needs to go. 6.1 is one standard deviation. So it's less than one standard deviation away, isn't it? All right. So we've got 35 would be there. And we want less than 35. So which side? So I'm going to shade in. And I would say always do that because they want evidence that you know where you're looking at, yeah? All right. So let me just ask you, in this context, this is the upper bound of the region. What can the lower bound be? Well, it could be, remember I said it could go on for, but actually in this case, because we're doing fish, doesn't it make sense to stop at 0? So I could just put, it shouldn't matter, the lower bound being 0 in this case shouldn't matter. Doesn't matter if you do something else, but we should at least go to 0. All right. So what does that region represent again? So it's the probability that x is less than 35. So if we work that out, okay, so on our calculator, do you remember how we did it? Second distribution, normal CDF, yeah. So my lower will be 0, my upper 35, the mean is 39, I've already got mine in there. We paste, press enter, press enter again in my case, I get 0.255996. 0.255996, or to 3 significant figures it is 256, which is what they've got in their answer, which is that. That's why I was saying I checked and we're kind of happy. So that means the probability of a fish being selected and being less than 35 is what? Give it me in different form. What does 0.256 mean to you? as a probability. Nope. It's just what is the probability being 0.256? So this is where I'm checking your transfer of what does a decimal mean? So the chance of getting a fish less than 35 is 0.256. Could you give me it in a different way? Yes. 25.6%. As a fraction? A little bit more than, so I could say, yeah, a little bit more than 1/4, yeah. So here's a question. How many of my fish would I expect to be less than 35 centimetres long? 25.6% of them, yeah? I haven't told you how many there are, so we can't do anything further, but we could say I would expect 25% of them, or a little bit more than 1/4 of them, to be less than 35 centimetres long. Okay? All right. Does that sound all right so far?
Yeah.
Not too...
With my calculator, I think... Oh, no, hang on. Look this time.
No, it's okay.
Unless, I don't know.
Okay, so then the next question says, Cliff catches 5 trout in an afternoon. Find the probability that at least 2 of the trout are more than 35 centimetres long. State any assumptions you make. So obviously the answer's there, but what in there would give you a clue in an exam situation that you were going to do binomial distribution? Because it's a tough one, isn't it? If you sat there and looked at that question, you were like, well, how am I supposed to do that? So we've got the answer. We know it's binomially distributed. So is there any clue in the question you could come up with? Yeah, so we've got catches 5 trout, yeah, and we've also got this where it says at least 2 of the trout are more than 35. So with a binomial distribution, are we what are the rules for assuming it's binomially distributed? It must be what type of situation?
When it's, you mean like it's either accepted or like I don't know how to say it without, like it's either ahead or not ahead.
Yes.
On a
Success and failure, we kind of
There we
said,
go.
didn't we? Yeah. So yes, something or not something. So what's the something or not something in this question? Exactly. Yeah. It's either more or it's not. So let's look at that then. So let's take this. Actually, should I just move it this side? So I'm now going to do Cliff catches 5 trout. So we are going to, when it says state any assumptions, so the assumptions will be that X is binomially distributed. Yeah, that's an assumption. What is important about that assumption as well? So it's allowed to be binomial, not just the success and failure, but that we have to say they're independent Why is that important? Do you remember we talked about this? If you have two die, if you roll a dice 5 times, what you roll once does not affect the other. So it's always a half, a half, a half, a half, yeah? But if it was taking a counter out of a bag, it might be 1 out of 3 is red, but if I put the red back in, it'd be 1 out of 3, 1 out of 3, that's fine. But if I took the red out and left it out, the probability would then be changed, right? So when we're doing binomial, it must be independent events, events where the second thing happening is not impacted by the first thing happening. So basically what we're saying is, if he catches a trout, the next trout size is not affected by the first trout size. And does that make sense? You think that's a fair enough assumption? Could you argue against that?
Well, it could just, couldn't it all just be more than? I mean, less than.
Well, so let's say I'm in because we're in a fish farm, right? They, you know what fish farms look like? Big pods and lots of fish. But if I chuck my net in and pick out a fish and I know it's more than 35, there's a good chance I'm in a pod where all the fish are over 35. So the probability of it being over 35, given that I've already caught one, could be certain, yeah, almost certain. So what we're assuming in this fish farm is that it's a normal, fish are small through to medium through to big, all kept in the same place. Yeah? But in reality, in the fish farm, you have the young ones, and then a bigger one, you've had the slightly older ones, and they don't eat each other then. But so we are assuming that in this case, they're independent of each other. So the probability is not changing. So how do we express a binomial distribution? What goes in? So it's n and p in your formula booklets. So that means x is binomial distribution. And what's n? So in this case, that's n equals 5. All right. What's p? The probability of?
So it's
Let's do the probability. Yeah? P. Yep, so the probability of success is the probability of x being more than 35. Yeah? So what's that probability? What's this one? Part A. Probability of less than. What's above it? Probability of more than. Okay, so if we go over here, look, if I did a little sketch. Oh, that's rubbish. It's really cool. If I did a little sketch and I've got my curve and I know that 35 is here, and I know the less than was 0.256, the more than, which is what I'm after now, is it's all of this region, no? So how do I work out the probability of everything else? 1 minus 0.256, yeah? Everything else. So what's that? 0.644. So the probability that we're greater than 35 is 0.644. Is that right? No, it's not. 744.
Is, yeah, 0.7.
You said it was near 0.75, didn't you? So the probability of this one is 0.744. Why would this be a good exam question at that point? What are they really challenging you with?
Like
using the previous one, but not just even directly using it. You have to use that in another step that's not obvious. Some people would just chuck that probability in because that's what they did in part A. Some people wouldn't even realise that part A goes into part, it checks on all those sort of levels, whether you understand what's going on. All right. So now what do we want? We want to know the probability of at least 2 or more. So we want to know the probability that x is greater than or equal to 2. Yeah? And how do we do that? Well, we want the probability that x equals 2. Okay. Plus the probability that x equals greater than 2. So 3 plus the probability that x equals 4 plus the probability that x equals 5. Okay. So how do we do all that? They don't have much information there in the answer.
Do we do with the find the number of ways?
Yes.
Like the C?
So we need C, 5 and 2.
Yeah.
We need C, 5 and 3. C, 5, 4. C, 5, 5. What's C, 5, 5? 1.
Yeah. C 5 2 would be the same as
10?
Yeah. And I got 5.
Okay, now that's the number of ways, but then we need to multiply that by the probability, don't we? That x is 2. So that means 2 of the fish are greater. So we need 0.744 to the power of 2, multiplied by 0.256 to the power of 3, because it's out of 5, yeah? Plus 10 lots of 0.744 to the power of 3 times 0.2. Oh, I'm running out of space now, aren't I? This is getting messy. So, write it out properly. 0.744 to the power of 3 times 0.256 to the power of 2 plus, what was it, 5
Yep.
times 0.744 to the power of 4, because it's, 4 there, times 0.256 to the power of 1, plus, finally, one lot of 0.755 to the power of, 744 to the power of 5. Yeah? Because I've gone through those 4. So it's tricky to see, isn't it, with my writing? So I've got that one, then a plus with that one, then a plus with that one, then a plus with that one. So that's the x equals 2, this is the x equals 3, this is the x equals 4, this is the x equals 5. Right, I'll let you work that out. So we've got 0. You confirmed, yeah? 0.983.
Yeah, that's it.
Right.
You know how crazy you sound?
So that's the probability that x is at least 2, right?
Yep.
So it's nice to confirm, even though they've only got that one number there. Now, there is a way on our calculator, but I'm not going to do it today. It's good that you've done that whole process. So let's talk the next bit. So that's the probability that I get 2 or more that are over 35, right?
Mm-hmm.
Find the probability that a trout caught is longer than 42 centimeters, given that it is longer than 40. So, do you remember the given that, the conditional probability stuff? All right. What is the probability that I pick someone that studies geography, given that I know they study maths? Yeah, that limits the denominator, doesn't it? Right. So you can see, right, in this question it says find the probability that a trout caught is longer than 42, given that I know it is already longer than 40. Now, why might that be the case?
Does that mean you're lower? Wait, is this?
Well, this is where we now need to add in the next phase of it, which is, what's the formula we've got for that? We've got the probability of A given B, yeah, is equal to the probability of A, was it, and B divided by the probability of B. Is that the right way around? Can you confirm?
Yes.
Okay. So what they've got in their solution, so we'll look at what they've got. So they've got, they're saying that therefore the probability that the length is greater than 42, given that I already know that the length is greater than 40, well, that can be found by doing the probability that the length is greater than 42 divided by the probability that the length is greater than 40. Why have I only got one thing on the top? Because this is the and bit, yeah?
Yeah.
So where's their and? Why have I not got both? Well, isn't the probability of 42 already over 40? Isn't 42 already over 40?
Yeah.
So 42 on its own is the same thing as 42 and 40.
Oh, yeah.
Yeah? Right, so how are we going to find the probability that it's greater than 42? So this is like a paper 2 question, right? This is where you struggled. What should be your mentality for a paper 2 question?
Look back.
Yeah. Look back at what we've been doing, right? It's not a standalone question. It's part of a bigger picture. So what have I done that is all about probability of a more than something? Yeah? Where did I start this problem? I didn't. That's not the first thing I did, or we did. Okay. And how did I do that? Just by... Yeah, I just did my normal distribution stuff, yeah? So basically what we're saying is that I'm looking for this time, length is above 42, right? Simple as that. And then I'm looking for the length is greater than 40, which is just past the mean, like that. Yeah? So really, there's not much more to this. We've got our calculator. What do we use, binomial or normal? It's normal, because what was special about the binomial bit of it? So I can recognize it. What are we not told about in this final bit? What do we not care about? We're just saying one fish, right?
Yeah.
Whereas the binomial bit was, yeah, there were more fish. There was 5 fish, the probability. So there's your clue as to binomial. I want 2 from 5, 3 from 8, right? This normal distribution is just if I pick a fish, yeah? What's the probability of it being? So I'm going to use my normal CDF again. All right, what do I put as my upper and lower bounds this time? Yeah, should we do the bottom one first, yeah? So let's put the upper bound, lower bound as 40, because we've got to go up, yeah? What do you want to put as your upper bound? I'm just going to put a big number that doesn't matter, as long as it's big. That really doesn't, I just click randomly there. Yeah, just make sure it's big enough. Chuck another one on if you're a bit, concerned. All right. In fact, you'll see on it when you open it up, it says 1 times 10 to the power of. Yeah. That's what it's doing. 1 with 99 zeros. So just chuck a few more on if you're worried. All right. What's the mean? 39. What's the standard deviation? 6.1. Let's paste that. Enter, and we get 0.435. Yeah, should we go 0.435? So that's the bottom one, 0.435. And then we've got to do the same for the top. So let's do it again. Distribute, normal. This time the lower bound is 42. Upper we stick the same. Everything else is the same, so it's nice and quick. and we get 0.311. And then if we do that calculation, 0.311 divided by 0.435, we get 0.71. Well, I got 5. 0.715, yeah? Why is there 0.716? I rounded here, right?
Oh, yeah.
So if we didn't round there, we'd have got the 7. But, you know, technically, if we're going to round to 3 significant figures at the end, we don't do it until the end. I should write it to 4. But I haven't. It's fine. You'd be absolutely fine if you gave this. All right? Okay. Are you okay with that?
Yeah.
So that bit was quite easy, but the hard bit was using the formula, wasn't it?
Yeah.
Or not even using the formula, but deciding the formula, and getting the numerator, understanding that 42 and 40 is already the and bit. All right? So then the final part of the question, which is all the added little extra mark or so, determine if the events greater than 42 and 40 are independent. So read what they've got there. Since the probability of 42 given 40 is 0.716, okay, and greater than 42 is 0.311, the events are not independent. So why is that? What they saying? Sort of in that area, isn't it? But if you think about it, 42 and 40 given 40, yeah? If there was... So you remember this could have been the probability of that and that, yeah? We stick them together, right? Now, do we get... All right, what they're saying is 0.715 is the probability of that, and 0.311 is just the 42, all right? So what are they suggesting? What does it say here, by the way? Apply the definition of independent events where? So they're saying if the probability of A given B is equal to A, then A and B are independent. All right? So because this number, all right, is not the same as this number, it means they're not independent. And it kind of makes sense anyway, doesn't it? Because we've already said greater than 42 includes... No, sorry. Greater than 40 includes all the greater than 42, right? So one impacts the other. So they're not going to be... If I take a fish out that I know is greater than 40, right, then that will impact the greater than 42... sorry. If I take one out that I know is greater than 42, it will impact the ability to take one out that I know is greater than 40, right? Because they overlap. Okay, so